Hello everyone, my name is Karan Chauhan and I am from IAPS DAVV, currently studying in my second year of MTech IT. I am currently in my fourth semester. So today in this video, we will be discussing about inheritance in Python. We will be seeing what is inheritance, the purpose of inheritance, the types of inheritance with some examples as well. So without all further ado, let's start the video. So now, what is inheritance? Inheritance can be defined as a way through which a class inherits methods and attributes from another class. As you can see, we have a class named employee here, which is our base class. We have another class named programmer, which is a derived class or child class of our base class employee. As you can see, we have written the name of our base class in parentheses here. This indicates that the programmer class is the derived class of our base class employee. So now, what is the purpose of inheritance? Inheritance provides us with code reusability, modularity, object-oriented programming design. As we all know, inheritance is an important topic in object-oriented programming language. So now let's move forward. So now let's see some types of inheritance. We have single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. So we will be seeing all the types of inheritance one by one with their example code as well for a better understanding. So now let's start. So now first we have single inheritance. Single inheritance enables a derived class to inherit properties from a single parent class, thus enabling code reusability and addition of new features to the existing code. As you can see here, we have our base class name as parent class that contains a function f1 that prints this function is in parent class. Similarly, in our base class, we have function named f2 that prints this function is in child class. And through objects, we are accessing the functions of our base class and the child class that the object is made in our derived class. So as you can see, here is the output of our code. As you can see here, this function is in parent class, this function is in child class. So now moving forward, let's look at another type of inheritance. Now moving forward on to multiple inheritance. Multiple inheritance, like a family tree, in a way allows a child class to inherit from more than one parent class, combining attributes and behaviors from each. As you can see here in the code, we have a base class name as a person class that contains the function getDetails that prints details of a person. We have another class name as athlete that contains a function called getSkill that prints athletic skills. As you can see, now we have a derived class that is derived from both of the classes, person and athlete. This student class is a derived class from both classes, base class person and base class athlete. As you can see, after creating the object in a student class, we can access the functions of both person class and athlete class. After executing the code, we would have some kind of this type of output. Details of a person, athletic skills. So now let's look at another type of inheritance. Now, multiple level inheritance. Multiple level inheritance happens when a child class inherits from another child class, and that child class inherits from a parent class. This creates a chain of inheritance. As you can see in the code, we have our base class name as animal that contains a function named sound that prints animals make sound. Okay, so this base class has a child class named dog class that contains a function named breed that prints this is a Labrador. Okay, now this child class also contains another child class named as puppy that contains a function named age that prints puppy is 1 year old. Now we have created our object through our second derived class. After calling all the functions present in our second derived class, first derived class, and our base class, we get the output like this. Animals make sounds. This is a Labrador. Puppy is 1 year old. So this is multiple level inheritance going on like a chain. As you can see, this is our first base class, only base class, and now we have child class that is the child class of our animal class. And now this dog class acts as a base class for a puppy class, as puppy class is the child class of our dog class. Now moving forward, let's look at another type of inheritance. Next up we have hierarchical inheritance. In hierarchical inheritance, multiple child classes inherit from a single parent class, allowing for shared behavior across subclasses with unique attributes. As you can see, we have a vehicle class here. Okay, so this vehicle class contains two derived classes named as car class and bike class. So when created object in a car class and bike class and call the functions of their respective classes plus their base classes, we get the output like this. Vehicle started, that is present in our base class. Car is driving, our first derived class. Vehicle started, our base class. Bike is riding, our second derived class. So this can be explained as in simple terms that of single class containing two derived classes, and both can access the functions of their base class. Now let's move forward to another type of inheritance. Now let's have a look on our last type of inheritance, that is the hybrid inheritance. Hybrid inheritance combines multiple inheritance types such as multi-level or multiple inheritance to model more complex relationships. As you can see, we have a base class named person class. This person class has a derived class named student class. Now we have another base class named as employee class. Now we have another derived class, that is a second derived class of our person class and first derived class of our employee class. The person class has a derived class named student class. The student class has a derived class named working student class. That working student class is also the derived class of our employee class. When made the object in a working student class, can access the functions in a working student class, employee class, student class, as well as the person class. When the code is executed, we get the output like this: name Alex from our person class, grade A from our student class, salary $2,000 from our employee class, role part-time student and employee from our working student class. So this was all about the types of inheritance. So now let's have a look on some more details in our inheritance. So now let's have a look on diamond problem and MRO, method resolution order. The diamond problem occurs in multiple inheritance when a class inherits from two classes that both inherit from a common superclass. The issue arises then when there is a method in that common superclass and the child class inherits two versions of it through different paths. This leads to an ambiguity. To resolve this ambiguity, we have MRO, that is the method resolution order. All we have to do is print the name of our derived class student here as written dot double underscore MRO double underscore. This will trigger the matter resolution order and our diamond problem or the ambiguity will be resolved. Okay, so now let's move forward. Now let's conclude our video with some key takeaways. First, we have inheritance allows code reusability by letting classes share behavior, as we have already seen that in previous slides. Python uses five types of inheritance: single, multiple, multi-level, hierarchical, and hybrid. We have already discussed all the five types of inheritance. Python uses MRO to resolve conflicts in multiple/hybrid inheritance, as we have seen the case of diamond structure and MRO as well in the previous slide only. Diamond problem is handled safely using MRO, as we have already seen in the last slide. So this was all about inheritance, and these were the key takeaways in the conclusion of our video. At the end, I would like to thank you all for sticking up with me till the end. Thank you very much and have a nice day.